Hi, this is the golden ratio part 2, and the part 1 we left off in the Renaissance, so that's where I'm going to pick up. So this is an example of the Renaissance masters starting to use the golden ratio to generate their artwork. The Renaissance masters, Raphael, Michelangelo, Leonardo da Vinci, just to name a few, knew about the golden ratio because the Renaissance masters considered classical Greek art to be the highest form of expression. So they studied the ancient Greeks and their use of the golden ratio, and they started using it in their own works. So here's a couple of examples. If we look here at the red lines, this is showing some prominent areas or prominent values in the perspective. And then once again, here's another line. So what we're looking for is like intersections along the space to create the proportions based off the golden ratio. And here are the two schools of thoughts. That's why this is called the School of Athens. So we have mathematical school, and then we have the philosophy school on the other side. But here are the two main leaders, and we can see that there are two of them, and their height versus the height of the arch is based off the golden ratio. All right, so Da Vinci used the golden ratio immensely, and he even stated, "Let no one read me who is not a mathematician." Leonardo da Vinci's best friend was a mathematician, so he actually illustrated a lot of information for him. And in fact, we can see here, this is one of the pages from that book I was talking about. For Da Vinci, all things in nature are governed by mathematical rule. Growth patterns and forms of plants conditioned by mathematical principles and geometry. Art could be a science for Leonardo if erected on mathematical principles. And here is one of the famous pieces by Leonardo da Vinci, the Vitruvius Man. And the Vitruvius Man is actually based off of a physician's book. And the physician's name was Vitruvius. And he came up with these values, or he measured the human body. So from the groin area down to the feet, and from the groin area up to the top of the head, if we measure these pieces from the groin area to the bottom of the feet, and then the feet to the top of the head is the golden ratio. So even in the body, we can find the golden ratio. Another piece, which is the most famous piece or the most recognized piece of art in the world, is the Mona Lisa by Leonardo da Vinci. And we can see that da Vinci purposely placed her on the canvas to show the golden ratio. So the underlying intersection points exhibit the golden ratio. So from the tip of her nose down to her chin, and from her chin up to the bottom of her eyes shows the golden ratio. From that value down to the chin, and from the chin to the top of the head shows the golden ratio. The overlay on this shows what's called the golden spiral. We'll be talking about that in a moment. It also shows a golden rectangle and a golden rectangle and a golden triangle. So all three are exhibited in this piece of art. Maybe that's why she's so famous. By the way, if you want to see the Mona Lisa, it is located at the Louvre in Paris. This is a piece by Raphael. It's called the Cobbler's Madonna. And what's really remarkable about this is her face captures the golden ratio. So what I'm going to show you next is I'm going to show you a mask created by a plastic surgeon in Los Angeles that is based off the golden ratio that he uses when people come in to ask for their facial features to be modified. He uses the golden ratio mask to make their features more aesthetically pleasing to the eye. So here's an overlay of that mask on her face. So you can see that her eyes line up, her nose matches up, and her mouth matches up. It's pretty remarkable. But like I said, the Renaissance masters knew about the golden ratio and utilized them extensively in their artwork. Here's another example. This is Michelangelo, and this is famous. This is on the ceiling of the Sistine Chapel. It shows God touching Adam's hand, and right where they intersect, or where the two fingers meet, we can see the divine proportion is utilized. So from the left of Adam clear to the right of God's foot, and then from where the two fingers touch outward is the golden ratio. So this is really cool. And by the way, some people claim that if you look closely, God is sitting in a brain, which is really an interesting concept. Okay, so we looked at the golden ratio utilized in the Renaissance era just to show a couple examples of how it was used in artwork. Now we're going to see the golden ratio and how the Fibonacci sequence is intertwined. So the Fibonacci sequence, just as a reminder, because I know we went over this in the last section, the Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and goes on and on and on. It's an additive system, which means we add the previous two numbers to get the third number in the sequence. So 1 plus 1 equals 2. And then if we add 1 and 2, we get 3. And if we add 3 and 2, we get 5, etc. So Fibonacci numbers can be mathematically described, or can mathematically describe spirals of sunflowers, palm trees, pine cones, and artichokes. I know we saw examples of sunflowers, and we also saw some example of pine cones. I have included a picture of Salvador Dali, who's a great surrealist painter. The Dali Museum is located in St. Pete, in which I give tours. And I give talks about Dali and mathematics. So here we see a picture of Dali painting a sunflower because he knew about the golden ratio and the Fibonacci sequence and was very, very, very interested in mathematics and science. So we see him painting a sunflower here in this photograph. All right, so we're going to look at the numerical relation between the golden ratio and the Fibonacci sequence first. So here's how we're going to get a numerical relationship. We're going to take and divide a number in the Fibonacci sequence by that previous number. Symbolically, this is going to look like a sub n. A sub n just means some number in the Fibonacci sequence. Then we're going to divide that by a sub n minus 1. The sub n minus 1 means that number that is occurring before a sub n. Okay, this is a ratio. Remember, if we divide one by another, it creates a ratio. The n stands for the Fibonacci number's position in the sequence. So once again, we find some number n, and n minus 1 is a number that occurs before it in the Fibonacci sequence. All right, so here's what we're going to do. We're going to take the first two. So we're going to take 1 divided by 1. So the first two numbers in the Fibonacci sequence, and we get 1. That's not too bad. And then we're going to take the third divided by the second number. So 2 divided by 1 is 2. And then we're going to take 3 divided by 2, which is 1.5. And then we're going to take the next numbers in the sequence, which is 5 divided by 3. This creates 1.67. And then 8 divided by 5, 1.6. And we keep on going up and up through the different ratios. So the 11th ratio, 12th ratio, 13th ratio, etc. But we notice there's a pattern emergent. And that pattern that is emerging is from the 9th ratio onward. We can see that it's resting on 1.618. And if you remember from part 1 of this video, 1.618 is the golden ratio. So what I've done is I've created a chart for you to look at. And this chart is charting each number or each ratio that we found. And we see that it is resting on the value 1.618. If you've taken calculus at some point, you'll know that that's called a limit. It approaches 1.618 and it stays on that value. Okay, so inferring, making an inference from the data, as our ratio between a sub n divided by a sub n minus 1 increases, our value settles on 1.618, which is phi. So that's pretty remarkable. Some things in nature and art can be explained with the golden ratio and the Fibonacci sequence. Okay, now we're going to look at the Fibonacci spiral. And the image behind the Fibonacci spiral text is a nautilus shell that has been cut in half. So we can see the chambers. This is creating that Fibonacci spiral. So there is a visual connection between the Fibonacci sequence and the golden ratio. Okay, so how do we get this? So if I were to make squares, and each side is based off of the Fibonacci sequence, I'm going to have each number in the Fibonacci sequence. So we have square 1, which represents, which sides are 1 by 1. So that represents the first number in the Fibonacci sequence. And then the second number in the Fibonacci sequence is 1 as well. So I have a 1 by 1 square next to a 1 by 1 square. Okay? To get the third number in the Fibonacci sequence, remember I have to add the previous two together. So if I add the side for square 1 plus the side from the second square, which is also 1, I get 2. So now I use that side and extend it out, because remember it's a square, the sides have to be of equal length. I get a 2 by 2 square. Okay, so that's the third number in the Fibonacci sequence. And then I take the side of 2 along with the side of the 1. And when I add those together, I get a 3 by 3 square. Now to get the next number in the Fibonacci sequence, I add 3 plus 2. 3 plus 2. I get the side 5. So I have a 5 by 5 square. And then 5 plus 3 is 8. And then 8 plus 5 gives me 13. Now, if I create an arc through those squares, you will see what's called the Fibonacci spiral. So that's how it's created, and that is a visual example of the connection between the Fibonacci sequence and the golden ratio, because this whole thing becomes a golden rectangle. Okay, so that's pretty amazing. And once again, there's another image of that nautilus shell. So here are just some examples that we can find in nature that exhibit golden spirals. By the way, not all spirals are golden. So I want to say that one more time. So, you know, if I ask you to find a golden ratio spiral and you show me an Archimedean spiral, that is not a golden spiral. A golden spiral has to have those proportions. If you look at the, I guess they would be the opening of a fern, you can see the golden spiral. Inside a rose, there's a golden spiral. The snail shell is a golden spiral. Well-formed hurricanes create golden spirals. You can find the golden spiral in the tail of a seahorse. And if you look at some shells, will exhibit the golden spiral. So once again, just because the spiral does not make it golden, it has to be based off those Fibonacci numbers and the golden ratio. And that's it for now. So hopefully you enjoyed this video, and I'm going to ask you to extend your knowledge out on the golden ratio on a worksheet. So that's that, and enjoy.